We are going to look at negative exponents. This gets pretty tough just because students at this point of the year are not as good with integers as they could be, and you haven't been using math for the past couple months during the summertime, so haven't been thinking about negative numbers. So it gets a little bit tricky as far as the negative numbers go. But if you understand the concept, you understand the process that we go through, your product is going to be okay every time. Okay. There's several examples that I want to go through. I want you to get a little bit of each type of question. So in order to make this thing as short as possible, let's go ahead and get started. The general form when we are dealing with negative exponents. Oh, let's see here. Blue. If you have a number, let's call it a, and you raise it to the negative m, that is the same thing as 1 over a to the m. Nothing about this is negative. There is a very big difference between a fraction and a negative number. Okay? You can have negative fractions, but nothing about this is negative. This is the notation that we use when we're describing a very small number. All right? I understand it looks like your final answer would be negative, but if we had 3 to the negative 3, and then we had a separate question which was negative 3 to the third, that's definitely not the same thing. This answer is going to give you negative 27, so this cannot also give you negative 27. All right, so we'll look back into that. Let's see. All right, so let's look at just a very basic example here of what it looks like. We'll do it with a number first. All right, let's look at 8 to the negative 2. It's not 16. It's not negative 16. It's not 64. All right. The first thing that you do, we wrote the steps down in class. The very first step you do is, if you know nothing else, go ahead and put an equal sign and then draw your fraction symbol. All right. This just means, oh, I know that a negative exponent is not negative. It's another way of writing a very small number, another way of writing a fraction. Step 2 is you're going to put, well, step 2 has a lot of parts to it. You're going to put this entire power in the bottom of the fraction. You're going to take away the negative sign. You have 8 to the second power, and then you put a 1 in the top. All right, understood 1 that's in the top. It's kind of like saying 1 times 8 to the negative 2. And the 1 would go in the top. So you have 1 over 8 squared. If you can simplify the bottom of the fraction, simplify the bottom of it. All right, y'all know what 8 squared is. So write your answer as 1 over 64. And this would be your final answer. Notice how nothing about this answer has a negative sign, and it's not negative. It's a fraction. It's a really small number. 1 over 64 is incredibly small. All right? So this is the notation we use. You know, one way we could show this is if we had, or let's look at this example here. Let's do this color. All right, so if I have f, so this is just giving you a variable, f to the negative 7th. The directions are going to say simplify. Leave no negative exponents. Simplify. Leave no negative exponents. All right. Simplify. Leave no negative exponents. So it is going to be up to you when you get an answer for these questions, and if it has a negative exponent, you're not done. You got to recognize that there's still more work to be done because we don't leave negative exponents. All right? So why did it go all the way down there? So you're going to simplify, leave no negative exponents. So if we had, all right, it went all the way down there. anyway, these are your directions, okay? So if we have f to the negative 7, this is a question, okay? And you have to simplify it, and when you simplify it, you're getting rid of the negative exponents. We do not like leaving negative exponents in our answer. So you're going to use the same concept, the same process, the same logic. You draw your division symbol first. You put the entire power in the bottom of the fraction. You're going to put a 1 in the top, 1 over f to the 7th. And you can't simplify that anymore. I know that's not like an answer that y'all are used to getting. However, that is your answer, okay? 1 over f to the 7th. That is the same thing that we did above in the first example. It's just instead of a number, we used a variable, saying any number raised to the negative 7 is going to be 1 over that number raised to the 7th power. Okay? Again, notice nothing about that is negative. All right. This is kind of explains why negative exponents give you fractions, give you really small numbers. Okay? This will help explain it. 10 to the 5th divided by 10 to the 7th. Hopefully that's... Let me see if I can clean that up a bit. Draw 10 to the 7th. This is 10 to the 5th. Yeah, it didn't clean it up very much. Okay, we already know by talking about division, if the base is the same and you're dividing, you subtract the exponents. So the base is the same, which is 10, and you're going to subtract the exponents. 5 minus 7 is not 2. All right? 7 minus 5 is 2. We're subtracting the number on the top by the number on the bottom. So you would have 10 5 times. So let's say 10 times 10 times 10 times 10 times 10. And on the bottom, you're going to have 7 of them. I'm getting used to this stylus, so y'all bear with me. 3, 4, 5, 6, and then there's one more. Okay? Now, remember, when you multiply by 10 and divide by 10, those are inverse operations. They're going to cancel each other out. That goes away, that goes away, that goes away, that goes away, that goes away. And what do we have left? Well, we have nothing in the top. And that is not an understood 0, because 0 divided by anything would be 0. That would suggest that anytime you have a negative exponent, the answer is 0. There is an understood 1 in the top. It's kind of like saying 1 times 10 to the 5th. Because 10 to the 5th times 1 is just 10 to the 5th. So you'd put a 1 in the top, and you have 2 10s that are in the bottom. So that would be 10 squared. Or if you wanted to skip that step, you could say 1 over 10 squared, which is 100. You do not need to do all this every single time. You do need to remember if the base same you're dividing, you subtract the exponents. All right? And when you have a negative exponent, like if you did do that, you'd get 10 to the negative 2. And you would use the same logic. You get this guy over here, 1 divided by 10 squared. All right? All right, let's look at the next example here. Moving right along, little children. Okay. Use a little bit more algebra here. We have G to the 4th times G to the negative 7 times G. Simplify, leave no negative exponents. We're multiplying all these, okay? So if the base is the same you're multiplying, you're going to add the exponents together. I would suggest if you have negative numbers for your powers, come out to the side and write your integer work. You have 4. The base is the same you're multiplying, you add the exponent, so you're going to add negative 7. And then there's one more G right there, so you're going to add a 1. There's an understood 1 right there for this G. So we have 4 plus negative 7 plus 1. Well, anytime we have two signs touching each other, we don't like that. We want to get rid of one of those signs, or we want to make it into one sign. So if you add a negative, if you add a cupcake, that is, or I'm sorry, if I add a negative, if I add detention, that is negative. So you would just write 4 minus 7 plus 1. And when you have addition and subtraction in the same sentence, you just go from left to right. 4 minus 7 is negative 3. Negative 3 plus 1 will give you negative 2. Okay? So you would have negative 2 as your answer. So, or as your exponent, you would have g to the negative 2. And you're going to now simplify that power, because it has a negative exponent to it. G to the negative 2, you're going to put your fraction symbol first. You put g to the second power in the bottom. You put a 1 in the top, and you circle your answer because you can't do anything more than that. It's going to be questions like these, definitely. The one that we just looked at. It's going to be questions like that that are going to say simplify, leave no negative exponents, because sometimes you're going to have a negative exponent as your answer, sometimes you're not going to, or sometimes you're going to think that the negative exponent is your answer, but you know that we don't leave negative exponents. All right, we're going to start getting into the little bit more challenging questions here. All right, so let's talk about this concept here. We have 15x to the 10th. We're going to divide that whole thing by 3x to the 13th. A lot of kids, what they do is they decide to put a line separating the division. All right, division you read going in columns, okay? Multiplication, you would just go left to right. Same thing with addition and subtraction. But when you're dividing, you have numbers on top of other numbers, you look at the columns. So we're going to divide 15 and 3. We're going to divide x to the 10th divided by x to the 13th. So 15 divided by 3, that would give us 5. And then x to the 10th divided by x to the 13th, that would give you x to the negative 3. Now, we have a negative exponent. We cannot leave it like that. The exponent is only talking to what it touches. The exponent of negative 3 is only talking to the x because it's only touching the x. What is it not touching? It's not touching the 5. So what we're going to do is we're going to draw our division symbol, and we're going to put the whole power in the bottom of the fraction. You're going to put the power in the bottom of the fraction. In this case, that's x to the negative 3. It has nothing to do with that 5. That negative 3 exponent is not touching the 5, so it's not talking to that 5. So the 5 is now, basically, let's write this down. Long-winded video. Deal with it. Deal with it. I don't know why it keeps jumping all the way up there. Okay, so we're going to write this down here. And I'm going to say, there it goes. Positive exponents go in the top. Negative exponents go in the bottom, and you're going to take away the negative sign. All right. So let's see if I can move it over. Positive exponents go in the top, negative exponents go in the bottom, and you take away the negative sign when the negative exponent at the bottom. So x to the negative 3 goes in the bottom. The exponent for 5 is not that negative 3 because it's not touching. So if it does not have an exponent, it's an understood 1. There we go. Draw. So this 5 is going to have a 1, and that's positive. So since it is positive, positive exponents go in the top. We're going to have a 5, and you don't need to put the 1 right there. Negative exponents go in the bottom. Positive exponents go in the top. All right? Let's try another one. We're going to do 4a b to the negative 2 c to the 4th times a to the negative 4 b to the 7th c to the negative 5. A lot of negative exponents going on here. All right. We are going to rewrite this sentence. I'm telling you how to do this. I'm telling you how to get it right. Rearrange the sentence. It takes 5 seconds. Watch. I'm going to put the numbers with the numbers, the A's with the A's, the B's with the B's, and the C's with the C's. When I say put them with each other, they're going to be next to each other. I only have one coefficient here. I only have one, quote, number. All right. I have a 4 that is in the front. So I have a 4. I don't have a coefficient over here. So he's all by himself. Oh. So then I have my A's. I got times A, and I got one more A. So I've got times A to the negative 4. Okay? Then I'm going to have my B's. That's B to the negative 2 times B to the 7th. And then my C's are going to be C to the 4th times c to the negative 5. We have not done any math yet. All we've done is rearrange the sentence. We put the A's with the A's, the B's with the B's, and the C's with the C's. All right? 4 is not being multiplied by anything. We're going to leave that as a 4. Now, A times A to the negative 4. This has an exponent of 1. So if the base is the same and you are multiplying, you add the exponents together. 1 plus negative 4. Well, a positive and a negative, you want to rewrite that as just a negative. It's 1 minus 4. So you're going to have A to the 1 minus 4, which is negative 3. When you combine 1 and negative 4, you get negative 3. We're going to leave it like this. Leave the negative exponents right there. The next step is going to say simplify the negative exponents. B to the negative 2 times B to the 7th. You're going to get B to the 5th. And then C, you have C to the 4th times C to the negative 5. You're going to get 4 plus negative 5. And the last I checked, that's negative 1. This is not your answer, little children. You do not ever leave negative exponents. The directions are going to say simplify, leave no negative exponents. So, in this case, 4 has an exponent of 1. That's positive. That's going in the top, baby. A to the negative 3, negative exponent, goes in the bottom. Take away the negative sign. B to the 5th, that's a positive exponent. It goes in the top. And then C to the negative 1, that goes in the bottom. Take away the negative sign. And you could put a 1 right there if you want. You don't have to. That's not generally how we write math. But you can. All right. This is your final answer. Can't do anything more to that. We combined the A's, the B's, and the C's. No coefficients to combine. And then we left no negative exponents. I want to show you just kind of one more concept here. If we have, I don't know. We don't use D very often. Maybe that's why. Let's do D to the negative 7 divided by D to the negative 9. If this is a multiple choice test, D to the, like 1 over D to something, or it's going to be D to the negative. I understand you see all these negative signs right here, and you're like, oh my gosh, my answer, the exponent's got to be negative. So you automatically go with that answer. That's incorrect here. If the base is the same, you're dividing, you're going to subtract the exponents. So if you are if you're subtracting the two exponents, the first exponent is negative 7. The next exponent is negative 9. And you are subtracting those. If you put negative 7 minus 9, the whole thing's wrong. Because you'd get negative 16. That's not the same thing. 2 negatives is a positive. When you take away a negative, if I take away a detention, that's really a positive thing. if I take away a negative. So you get negative 7 plus 9, and that's the same thing as if you flip-flop them around and be 9 minus 7. That gives you a positive 2. So your answer in this case is D to the positive 2. Yeah. Now, that's one way you could have answered it. The other way you could have looked at it, let me see if I can scroll down here. That says D to the negative 7. Well, here. Y'all got that written down, yeah? Or y'all have got that? Okay, I'm just going to erase this. All right, another way you could have answered this question, I think this one's a little bit easier. I want to show you both ways. Put as many tools in your toolbox as you need. If it is a negative exponent, you put it in the bottom of a fraction, yeah? And you take away the negative sign. But what if it's in the bottom of a fraction and it's negative? How do you think you get rid of that negative? You put it in the bottom of another fraction? No, if it's in the bottom of a fraction and it's negative, you put it in the top and make it positive. Okay? So now you have D to the 9th divided by D to the 7th. That's a lot easier question to answer. That just gives you D squared, which is exactly what we got in the last question. I might do a part 2 of this just to show you a few more examples of what you might come across. But this is just kind of the basics for negative exponents, okay? Do the next right thing. I believe in you.